Yeah, welcome back to my YouTube channel, and we're back to the series of special integrals like this form. So this will be the third special form of the what of integrals like this. And I've talked about two. I've talked about 1/x squared plus a squared. I've talked about 1/x squared minus a squared. So the third special one will be what? Be this a squared minus x squared. Let's go on to that. So from this, I know that the integral of the x over x squared minus a squared is equals to 1/2a natural logarithm of what? Of x minus a over x plus a. And you have a bar plus c. So you have a bar plus c. This is the actual form of the word of an integral of this form, x squared minus a squared. Are you getting? So from this, how do we go to this having this form? There are two ways of going about it. The first one is this. Since I actually know the form of this, now the actual form of this, I've talked about it in my last video. You can check it will be the video of number 2 on the special integral playlist. So I created a playlist and the special 9 integrals. This is the second special 9 integrals among these 9. This is the second one. So the third one is this. Now, but since we know this equals this, we don't have to waste time on this. There's a way of getting through this, which is this. So since here is a squared minus a squared, remember a squared minus x squared is the same as minus of x squared minus a squared. So since I know this one, I know this one indirectly because this form is the same as this. Then from there, I know the integral of the x over x squared minus a squared is the same as minus of the integral of the x over x squared minus of x squared minus a squared, because the minus multiply this, that gives us the minus x squared, and minus multiply this, that gives us the plus a squared. So plus a squared minus x squared is the same as this. You can see. Then from there, this is a minus, which also means a minus 1. You can bring the minus 1 as a constant out. So you have a minus 1 here, and you have the x over x squared minus a squared. The integral of this is this. From my last video, I gave a proof on how we got here. So that means this will be equal to minus of the whole of this minus 1/2a natural logarithm of x minus a over x plus a plus c. I just my answer. I just have a minus here. But mind you, in logarithm, so I'll be jumping back to here. So I think you guys have seen this, so I can clean this off. So in log, I know logarithm of x raised to power minus 1 base a is equals to minus log x base a. In logarithm, you can bring, let me use n. So to generalize it, I'll be using n. In logarithm, you can bring a power to the back of a logarithm. So when you have a power on a logarithm, you can bring to the back of a logarithm. the same works is what? With minus 1. So if I have log of x is power minus 1, let's say base 2 for example, it's the same as minus log x base 2. They are both the same. Let me use this, let me write my x like this. So this and this are the same in logarithm. So from there, that means this minus can come to this place. And that means you have the x, so you anyway you have x squared minus x squared is equals to 1 over 2a natural logarithm of x minus a over x plus a all raised to power minus 1. Because this minus 1 comes to the power. You can see this and this are equivalent in logarithm. That means I can bring the minus 1 back here or return it back. But now in this case, we're taking the minus 1 back to the power. And that means now we know this is a what? This is an indices question. An indices, when you have a over b raised to power minus 1 is the same as 1 over a over b. And that gives us 1 divided by a over b, that is equals to 1 times b over a, which is equals to b over a. So what am I proving here? What I'm proving here is this. Note a over b raised to power minus 1 is equals to b over a. You can see this is the proof of this to what? To this. That also means this particular what we wrote here is the same. Is the same as, so whenever I have an integral of the x, a squared minus a squared is equals to 1 over 2a of x plus a over x minus a plus a c. So what did I do here? You can see I have a minus 1 here. So this minus 1 is a power. It translates the denominator to the what? To the numerator, and the numerator comes down to the what? So that is what happens here. So you have x plus a over what? Over x minus a, which is the right form of this. Also, though most times people like having it in this form of 1 over 2a of a minus, sorry, a plus x over a minus x plus c, which I also love. So you can write it this way or you write it this way. They are the same thing. Why? Because in absolute, when we talk about absolute function, the absolute of a negative number is always equals to what? X. Are you getting me? So the absolute of x minus a is the same as when I have a minus x. And what is the absolute of minus of a number? Is that same number. So this and this are the same, because in absolute of a function, whenever you find absolute value, now the meaning of absolute means it absorbs the minus or the what or the plus of a number. If I say the absolute of minus 5, my answer is 5. The absolute of 7 is 7. So in that case, this and this stuff leads to this. So that means absolute of absorb the minus, and I have just what? A minus x. So this and this are in the same form, no difference. So the answer of this is equal to this. I made a mistake. There should be logarithm. So here is a logarithm. Here is a logarithm of what? Of this. From there we can go to an example. Okay. So example 1 on this, that means the integral of the x over 25 minus x squared. That gives integral. I've told you always what? We change it. So this becomes the square root of 25 squared minus x squared. And my a here will be the square root of 25. Can you get that? And that is equals to what? That is equals to 5. So that means my answer here, the integral of the ax over 25 minus x squared will be equals to 1 over 2 times 5, the natural logarithm of 5 plus x over 5 minus x, and you have a constant. That will be your final answer. So you don't have to go to the initial solving of this. You just have to what? You use the formula and find your answer. That is number 1. Number 2, the integral of 74 minus x squared because integral of the x over square root of 74 all squared minus x squared. So my a here is what? Square root of 74. Can you see? And my final answer will be equals to what? 1 over 2 square root of 74, and that will be the natural logarithm of square root of 74 plus x over square root of 74 minus x plus a c. That will be my final answer on that. So that will be a series on the what? On x squared minus x squared.